This is Brian Putt. Today I have another valued information exercise to review. And I'm going to be using here Enterprise 4.0. This is the new purchase software from Probability Management. And I'll be demonstrating some of the features of that Enterprise 4.0 tool. So today we're going to talk about whether you should buy a new or a used car. And let's go through the frame in this session, and then in subsequent videos we'll go into the model and the analysis. So in that analysis we're going to be talking about looking at the value without information, the value with information. We're going to look at repair costs for the used car that are continuous. We're going to talk about tornado charts and actually an expanded tornado chart. And then we're going to look at sensitivity charts and to look at the optimum decision policy as a function of that sensitivity. And framing an opportunity, we want to start with an issue list. And here we might have all the subject matter experts to get together and they start listing all sorts of things. And so I started to do that with this particular evaluation. And the reason for getting everyone together is so you can get some multiple views from the subject matter experts. They're all going to have a little bit different perspective on the problem. And they're going to raise different issues that may be important to the analysis that you would miss if you just had one segment or if you didn't have them interact with one another. You did them separate interviews. So I really encourage you to have them all together when you do this framing session. And also by having them all together, you're going to help to define the interface between these different functions. You wouldn't want some particular aspect of the project to be left out because the one function thought the other function was going to be doing it. So anyway, have everyone together as you put together this issue list and then define each of those issues as decisions. This is a given decision or a focus on decision, and here's some uncertainties and here's some value measures. So what else? So now we're going to bring those decisions over to decision hierarchy, and in this particular case, it's going to be a given that we're going to buy a car. We're not going to consider not buying a car. So we're going to buy a car. The question is whether it's a new car or a used car. And then there's a question, and this is where the value information comes in. Should we get a cost estimate for the used car before buying it? In other words, I just go to the lot and the salesman says, oh, this is a great car, nothing's wrong with it. Or do I take it to mechanic and get a review to see how much it might cost to fix some of the things that are there so it looks closer to the new car? And then based on what I hear from the mechanic, what is the decision policy? Do I buy a new or a used car? There are some other tactical decisions, such as the type of car to get, the color of the car, features, blah, blah, blah. We'll decide those later. I guess in the case of the used car, that there's kind of known what they are. In the new car, I could get some different options, I guess. But we're not going to consider those in this analysis. So here's my strategy table. I have an option of buying a new car, buying a used car. This is without information. And if I get information, buying a used car only with the low cost of repair, or buying a used car with the low and mid cost of repair. The assumption being that if it's a low cost, I would buy it. Because if I wasn't going to buy it with the low cost, then why even go through that effort? I just buy the new. And if I was going to buy the used car in the low, mid, and high, then there'd be no reason to get the information either. I would just go buy the used car. So these are really the only options here for scenarios. And then what I've done is to show what those decisions and which options go with each of these strategy themes. So let's talk about this buy used only with the low cost of repair. Let's look at that diamond. So I am going to get a mechanic review. I can either get an extensive or a quick review. There's two types of reviews I can get. The decision policy based on the mechanic review low cost, I'm always going to get the used. That's what I said earlier. The decision policy based on the mechanic review of a mid cost is I'm going to get a new car. That's what this option says up here. buy used only with the low cost. And the decision policy based on the high cost is I will get a used car. All right. So anyway, that's how the strategy table kind of thinks through this. And we're actually going to look at these different decision policies and determine which is the right one. So here's the influence diagram. And it kind of starts with, do I get a mechanic review? Yes or no. And if I don't get a mechanic review, I'm going to get a new or a used car. I have to make that decision right away. On the other hand, and then I have, depending upon what I do, I have the actual cost to repair, I have the cost of the used car, and the cost of the new car. These three things then feed into the total cost. On the other hand, if I get a mechanic review, there's a cost for that review. At the same time, I get the results of that review. And the results of that review will depend upon the reliability of the repair. We actually probably should say the reliability of the inspection. And the actual repair will also impact the results of the review. And that's how the Bayesian probability matrix works when you start to invert it. Now, given that I have the results of the review, I can now make a decision on whether I'm going to get a new or used car. And then these three factors come into play again and to give me the total cost. So that's what the influence diagram looks like. I've shown this arrow here is red because this is saying the result of the review are conditional on the actual repair costs, which I don't know, but I'm going to include that in the probabilities, and then we'll do the Bayesian inversion to do the analysis. Okay, I'm going to stop there, and in the next video we'll look at the model itself.